In this section, we look at our first kinematic variable, position. And understanding position is going to be the most important part of understanding the motion of an object because it will tell us the location of that object. So let's get started looking at it. All quantities in physics have a symbol. In this case, we indicate our position by the symbol x. Now we may change that to y later, depending on the situation, but for now let's stick with the symbol x. Our position also has units, and since it's a measure of distance, these units are primarily meters, but also kilometers, centimeters, etc. One of the things that students often overlook is that before we can even start describing position, we must make two choices. The first of these choices is what's called an origin, the location where the particle is zero. The second is the choice of what's called a positive direction, which is the direction from the origin where position is positive. And to understand this, let's say I have a cart confined to roll back and forth on a track. Let's draw the track in blue as you can see here. And now let me go ahead and indicate the position of our cart by this dot. Now, if I were to ask you the question, where is this cart located? The first thing you would ask is relative to what? Well, that zero position that we draw is the origin. The next thing that you can do is to say, okay, over here to the right is the positive direction. Now, once we've done that, then we can measure the distances, say, oh, this is 1 meter, 2 meters, 3 meters, 4, etc., and even into the negatives. And now we can see that our object is located at about 2.2 meters. This choice has allowed us to locate our particle on a number line, and so now we can go ahead and start graphing it. So let's get some practice with graphing. In this first one, we're looking at a person that's standing still at 1 meter for 4 seconds. So let's first draw our axes, label them, time on the horizontal, position on the vertical, and make sure to include units. Now this person is at 1 meter at 0 seconds, 1 meter at 1 seconds, 2 seconds, onwards, and so what we realize is that this is just a horizontal straight line. In this next example, a dog that starts at 1 meter and then walks in the positive direction, well, we'll still need to label our axes like before, time on the horizontal with the units, and position on the vertical with its units. And then if the dog starts at 1 meter, well, I think it's clear that as it walks along in time, it's going to get farther and farther from the origin. And so in this case, its position is going to increase, as you can see here. Now, I didn't really say at what speed, I just said it increased at a constant speed. So if it was going much faster, it might look like this green line here. And if it was going slower, it might look like this red line here. Part C is similar. We again label our axes, and then we put time on the horizontal with its unit and position on the vertical with its units. Because the cat is located at 3 meters and moving in the negative direction, then its position is going to become less positive. So it might look like this blue line here if it's walking at -1 meters per second. But if it were walking much faster, you might see this green line here. And if it was walking much slower, it might look like this red line here. So related to position are a couple other physical quantities that we will study. And these don't come up quite as much, but we will need to know them because we will see them periodically. The first one is displacement. Displacement is the difference between the final position and initial position. It's given the symbol delta x. The delta symbol has a specific meaning in physics, and it means change. So when we write down our formula, delta x simply means the change in x, or in this case, x final minus x initial. The next quantity that we're going to study is distance traveled. This is the distance the object travels along its path. This will come up only occasionally. It is always positive, but the reason we don't see it that often is that it can be quite tricky to calculate because it often requires calculus to do so. So let's go ahead and look at an example with these two quantities. And in this case, what we see is we have a dog walking in a loop so that it ends up where it started. In part A, we're asked what is the dog's displacement, and I think it's pretty clear that its change in position is 0. So its displacement is 0. Is this equal to the distance traveled? Well, no, I think it's pretty clear that the distance traveled is certainly not 0. And as I said, it's always positive, so there's no way that the distance traveled could be equal to the displacement.